Good afternoon, guys. Coach Locke here. Today we want to talk about simplifying radicals. Don't have my marker board because I'm not at school because of the way the roads are, so I'm going to make use of Jamboard and little screencast here. So on this first page, we've got two different radicals. We've got the square root of 36 and we've got the square root of 60. So the first thing I want us to think about is what a square root means. And essentially, it means if you have a square with an area of 36, what can you multiply a side and a side by to give you your area of 36? Now, remember, with a square, it's got to be multiplied by the same thing. So in this case, 6 times 6 gives you 36. So the square root of 36 is just 6. And this is what we call a perfect square. We've got our list of perfect squares. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. And you can keep going down the list. And it's going to be helpful when simplifying these things if we understand what our perfect squares are, and even up, towards the 100 mark. And 9 times 9 is 81. I'll stop there. All right, square root of 60. If we type that into a calculator, we're going to get somewhere around 7.6, 7.7, because it's between 7 squared and 8 squared. It's a little closer to 8 squared, so that's why I say the number is going to be closer to 8 as far as the 7.7, or so somewhere in that vicinity. So what we want to do here is we want to take this 60 and we want to break it down. And I'm going to show you a couple different ways to do it. So we want to find a factor of 60. In other words, what can I multiply to get 60 that is one of my perfect squares? Well, if I do 60, and all you really have to do is 60 divided by, and just go down your list. 60 divided by 4 gives you 15. So we can say the square root of 60 is the same as the square root of 4 times the square root of 15. And we can actually write it out that way. Square root of 4 times square root of 15. And if you type that into a calculator, you're going to get the exact same answer as you would if you typed in the square root of 60. Okay, from here, we want to break down this square root of 4. Square root of 4 is 2. And I can't do anything to the square root of 15 as far as simplifying it, because I can't divide 15 by any one of these perfect squares. So if you were to go in and you were to type in the square root of 60, or square root of 4 times square root of 15, or 2 times the square root of 15, you would get the same answer. All right, another way you could think about it is you could take this square root of 60. I'm going to come over to the side just a little bit. And you can write out a factor tree. Okay. And really, any factor is going to work here. We could say 6 and 10. And then we want to get down to where we have all prime numbers. 2 times 3 is 6. And 2 times 5 is 10. So from this point, we're going to take numbers that are the same, and one of them is going to go outside our radical. Any number not the same is going to go inside and be multiplied by each other. All right, I've got two more examples for you that I want to work through. Square root of 96. And I'm going to do this a little different. Um, I think you'll see why. So 96 can be broken down into, let me write that. I'm just going to skip that one step. 4 times 24. Okay. Square root of 4 is 2. And we're left with the square root of 24. But if we go down our list of perfect squares, which you can see right here, I realize that I can also divide 24 by 4. And 4 times 6 is 24. So then I end up with 2 times the square root of 4, which is 2, times the square root of 6. So I end up with 4 square roots of 6. And the reason that happened, and I had to pull out a perfect square twice, is because the largest factor that's of 96 that is a perfect square is actually 16. So if I would have broken down this one into square root of 16 times the square root of 6, I could have said square root of 16 is 4 times the square root of 6. And I get to the same answer, but sometimes we can't always find the largest common factor that's perfect square so easily. Okay? To give you this same thing in the other way, and I don't care which way you do it, it's just a matter of which way you prefer to do it. All right, we already know 4 and 24 works as factors. 4 can be broken down into 2 and 2. 24 into 4 and 6. 4 into 2 and 2. And 6 into 2 and 3. All right, so one of these will go outside, and one of these will go outside. So I get 1, 2 times 1, 2 is 4, and inside will be a 2 and a 3. All right, for the last one, just to reiterate what happened in the last one, I've already got 2 outside. So I'm going to get 2 times the square root of 20, which I'm going to break down into the square root of 4 and the square root of 5, which gives me 2 times square root of 4 times square root of 5. 2 times 2 is 4, and the square root of 5 we cannot divide by any of our perfect squares, so we leave it as the square root of 5.